Chapter 4 is about nuclear chemistry. In this chapter, we'll talk about natural radioactivity, nuclear reactions, and half-life of radioisotopes. What is natural radioactivity? We could have isotopes that are radioactive. These are isotopes that have a very unstable nucleus. Usually, they have more than 20 protons in the nucleus. And what they do, they emit radiation to become more stable. They can emit certain types of radiation, and then they can either become a different isotope or they will become a different atom. There are different types of radiation. The definition of radiation is the energy that is emitted by an unstable atom in the process of becoming more stable. One type of radiation that we're going to discuss is the alpha particles. Alpha particles are identical to a helium nucleus, so helium with the mass is 4 and 2 protons in the nucleus. The other type of particles, the radiation, is beta particles. These are very high energy electrons with a negative charge. They have no mass, but they have a negative charge. Another type of radiation is positrons. They are similar to beta particles, but instead they have a positive charge. And gamma rays, they are very high energy radiation, and they are written like this. So the summary, these are the particles that we are going to discuss. Alpha particles, beta particles, a positron, gamma. Then we have a proton, that's another type of radiation, and a neutron. A neutron has no protons, but it has a mass of 1. So there are effects of radiation to our bodies. What is the effect? Well, the ionizing radiation passes through the human body and interacts with all the molecules that are in there, producing H2O+. This is a cation, and they can cause very undesirable chemical reactions damaging the cells. So radiation protection is required when we're dealing with radiation. So for example, for our alpha particles, only clothing is okay. Beta particles, coats or gloves. Then when we are dealing with gamma rays, we'll see that we need shield or a lead shield or a thick concrete wall. The amount of time that we spend in front of the radiation is also gonna matter. If we spend a little bit of time in front of the radiation, the consequences will be less than if we spend a lot of time in front of it. Let's deal with this problem. Which form of radiation has a mass number 0 and a positive charge? So 0 mass, positive charge. So this is a positron. Nuclear reactions. So the reactions that we're going to learn are decays. We could have alpha decay, which means that an atom lost an alpha particle. We will also discuss beta decays and so. So when we have an atom that is very unstable, it will lose an alpha particle, and as we know, an alpha particle is denoted like this. It has a mass of 4 and it has 2 protons. So when we're doing a nuclear equation, we need to make sure that the mass number matches. So for example, if we have this compound, this atom over here, and we want to do a alpha decay, so what we're doing is we're losing one of these particles, correct? This is a alpha particle. So the mass is going to be 251 minus 4, that gives you 247. The next thing that you balance is the number of protons. We have 98. The alpha particle has 2, so this answer is 96. The next thing you do, you go with this number to the periodic table, element number 96, and that is going to be CM. So when this atom goes on the alpha decay, you obtain this one. So in order to follow the alpha decay equation, you write the incomplete equation, you determine the missing mass number, determine the missing atomic number, the missing symbol of the nucleus, the new nucleus, and then you complete the equation. So let's do it step by step. So we have this going under alpha decay. An alpha particle is this one, right? 2 protons for the mass. So the first thing is determine the missing mass number. So we take 224 minus 4, that is 218. So we know that in here we're going to have an element that has 218 as a mass. We do the same thing for the protons. 86 minus 2, that's 84. So we know that the atomic number of this element is now 84. So the last thing we do, we check what element is number 84, and we found that is PO. So when we write the symbol, will be PO with a mass of 218 and a atomic number of 84.